So a very warm welcome to everyone who has joined the presentation today. Good morning, good afternoon, wherever you may be. A very special welcome to the delegates and friends from Kingdom of Saudi Arabia, Dubai, where I've spent 25 years, and also from the authorities in India who are well onto the way to get the air handling unit or the airside specifications and airside things going in a good way. So far, we have seen energy related work on chiller side, which is 50 to 65% of the entire HVAC energy spent. And more emphasis today is being put on airside energy spend, and that is something which is now catching on due to the very fact that two things are happening right now in the world. One is the energy prices are constantly on the rise, and the effects of global warming are showing up. And that necessitates that and tells us that every drop counts. It is not just that we take care of the chiller side or the chill water and energy that we can reduce in their operation, but air side counts a lot. And going ahead, we need to get our air handling units right in order to save as much energy on air side as possible. So what is happening around the world? You can see energy performance of building directive in Europe, which was recast in 2008, talking about energy efficiency class for summer application of any project under subgroup 1. And manufacturers of air handling units in this region and the world over have taken notice of that, because a number of projects where these air handling units are actually supplied by people in this region. Let us go ahead and see what are the requirements of a good air handling unit, and what are the market forces, what are the designers, the building owners, regulators, and manufacturers telling us. What do they understand? They understand very well that air quantities are normally higher than what is required in winter mode, and this leads to higher pressure drop within the AHU. Dehumidification requires substantial energy. Technologies are today in place so that moisture from fresh air can be taken out with substantially less energy. Similarly, evaporative cooling, wherever possible, can be used to reduce sensible load by doing pre-cooling. Cooling to dehumidify and reheating to meet temperature requirements can produce a lot of waste of energy. Therefore, alternate ways need to be evaluated. Components that are not required and pose a pressure drop can be bypassed to reduce the internal pressure drop. Now, today's webinar, we are talking much about the labeling requirement for hot and humid region. So let us see what the hot and humid region basically means, and how does the humid region pose a challenge in front of the building owners and everyone who is into energy control these days. So the sorry, the picture on the left hand side is mainly pertains to the hot climate, and you can see a lot of area gets added when we talk about humid climate. And the picture on the right is basically all the areas where humidity poses a major concern and energy requirement on the air handling unit. Let us understand what the building owners are asking us, or what are the regulators asking us to do at this point in time? We have all seen uh, in the last few months or last couple of years, increased and dual ventilation rate requirements being posed by building owners and people who are into designing. Emphasis on compressor-less cooling for applicable periods is on the rise. Uh, Places like India, where we want to go out and provide cooling to the masses in hot and dry region with whatever power is available to us, uh, needs that we work on evaporative cooling and provide whatever cooling can be provided without the use of compressors. Day by day, we can all see that controls are becoming more and more intelligent and efficient, and use of IoT and related controls is going to, at some point of time, get into this air handling unit world and possibly, provide us an air handling unit which will self-adjust itself to use the minimum amount of energy and shift from one mode to the other, looking at energy predominantly. The other thing that the market is, or the specifiers and regulators are asking, is that reheat requirements be handled in a very energy efficient manner. Nobody is willing to spare strip heaters and electrical heaters for any reheat requirements. Similarly, with the increased rate of ventilation, heat exchangers, plate wheels, different types need to be used intelligently in order to bring down the cooling load or the cooling requirements in the first place itself. And we will talk about it in this webinar, and the experts who are to come in the next few presentations will go further deeper into things as far as these things are concerned. We need to keep an eye on the internal pressure drops. The internal pressure drops are the responsibility of the manufacturer. The external pressure drops obviously are done by taken care of in field design, and they sort of want that the internal pressure drops are properly designed by manufacturers, and they are labeled properly so that the total pressure drop when seen at site has the lowest component of internal pressure drop possible. And things like this in future need to be rewarded. That is what uh, the regulators and the market and the building owners are telling us. This is more of common sense boardroom talk rather than the other things which becomes a designer talk. So let us go ahead and see what is happening around the world. And to say, all around the world, people are working on these particular kind of things. And here is a slide of what is being done in India by ISHRAE under the expert guidance of Dr. Jyotirmay Mathur. Young engineer Nishant Gupta has produced a program where evaporative cooling, we can find out in hot and dry region, it brings in the temperature and humidity of different places. It is location specific, and it tells you out of 8,760 hours, how many hours you can meet an internal temperature and humidity automatically by providing just evaporative cooling. So this is a rough printout of that particular program, and it spans then into two-stage cooling, so to say. So we are all aware of two-stage evaporative cooling. First, we basically cool the air, and then we humidify it and leave it in space. Again, for hot and dry regions, this could be a great thing to incorporate on the airside air handling units in time to come in order to reduce the load itself. So let us look at what is being done in Europe. And Pedro Lapa is today with us, and these are some very, very good inputs that he provided to me. And you can see we can cool down the fresh air in low humidity regions, basically by providing a combination of evaporative cooling and plate heat exchangers. And upfront, we can bring down the amount of energy that you need to spend on your fresh air. And these good things are coming in, will come in, have to come in at some point of time or the other. Different countries are taking it at different paces. So again, a sensible wheel, the energy recovery in that of the sensible heat, enthalpy wheel, you then have enthalpy wheels or hygroscopic wheels, which take out more amount of moisture upfront. And if you look at all the wheels on a single graph, you see that they create different pressure drops for the airstream. And that is important because with different pressure drops, we have different amount of power being utilized in order to overcome that pressure drop on that particular wheel. Going ahead, some studies have been done in India and other places with various combinations of entering dry bulb and wet bulb temperature that exists in different parts of the country. And some places are low RH, we call them hot and dry. Some places are high RH, so the temperature does not go that high, but the humidity goes much higher. And when we run a 8,760 hours analysis on these particular things, we find that the energy spent is different with different pressure drops, and not all kinds of wheels come out to be the same thing, the same energy consumption. And this is what is telling us that it needs a very close look at these particular things. And the programs, the software which comes out and generates these particular or does the selection of these air handling units need to incorporate things like the weather data. Today it's available from AHUs, from other sources for around the globe. So softwares have become much more powerful. They can incorporate the weather data of almost every city in the world and provide you an analysis with the wheel characteristics as to what kind of which comes out to be the winner. So prediction of energy efficiency is not dependent on components only. I'm to say you can have a component listed in any of the certified sites, but you need an overall holistic number taking into account the local conditions, the air velocity, and the spacing arrangement, resulting in different pressure drops. And in time to come, intelligent use of IoT is going to come in, and bypass dampers are going to be controlled probably automatically, and make sure that the least amount of energy spent is done for providing the cooling and the fresh air to different places in different regions. So if you recall, we had done a webinar on filters, and we had shown how different filters can have different efficiencies for the same PM level required. And there are other factors which go into air handling unit design, like high fan efficiency grades. We are seeing how fan efficiency grades are changing now, types of fan, motor and efficiency class, we see improvement. And there are a lot of things that are being done on air side today in order to improve the efficiency of the air side system as a whole. So we also plan a webinar on energy recovery and energy efficiency of air handling units sometime end of May 2022. The purpose of that would be to explain these values PAT and PAH that you see on your screen. This is quite a complex task and not achieved in a webinar like today's in an hour or two. It would probably need what is called a workshop with so many people over there and people holding hands and taking you through the process of selection, the process of understanding how different wheels produce different pressure drops. I'm sure Pedro will be able to answer any questions today that you have in this particular regard. He was the chairman of the subcommittee, which came in and did all this good work. So coming to the fundamentals, the factors influencing energy consumption have to be taken on board. People will talk about airflow and external static pressure. But what I would like to emphasize as a designer and as a person who's keenly involved with net zero process and with carbon neutrality and things like that is that we require the energy class of good air handling units to be shown separately in databases or on printouts of selection programs with adequate justification so that going ahead, building owners can decide in their owner project requirements, the OPRs, as to what they are targeting in terms of energy efficiency for their whole building. So with that, I would like to share with you the screen from what is being done in India, ISHRAE Rama standard. It has also taken both mechanical performance and thermal performance into consideration, and heat recovery system has already been sort of added into it in order to arrive at the overall performance value. So it's basically the pressure drops, the fan efficiencies, the thermal performance, and heat recovery and air velocity, which are all going into the formation of these standards as of today. And hopefully it will show up in the region and expand globally along with what is being done in Europe. So here's the energy label that Eurovent has come out with. You can see on the left hand label snowflake, and on the right hand label the sign of the sun, which tells you basically that one is the winter condition, the other is the summer condition, and the differences will be brought out by the methodology of this, and the differences will be brought out by the speakers who come in, the experts who come in next on these particular things. And with that, I would like to sign off, and I'll be there for the question and answer session along with the others to take on any questions that may be there for basically the philosophy of this particular thing that we are trying to put forward in order to save the last bit of energy. So Marcus, over to you for the rest of the presentations. I'll be there for the question answer session and the panel that we have at the end.